Survival in this dense riverbank environment demands more than just endurance. It requires an eye for hidden potential. Clearing the site is the first negotiation with the forest. Thick, woody vines must be removed not just for space, but to minimize insect pathways to the planned foundation. Every swing of the machete serves a dual purpose, yielding green bamboo that transitions immediately from obstacle to building material. Freshly harvested bamboo is heavy with water, making it pliable and less prone to splitting during structural cuts. The raw material dictates the design. Work begins before the green wood has a chance to dry and stiffen. Mud and standing water are the enemies of a dry camp. A temporary bridge establishes a stable footing, distributing weight across the saturated soil to prevent sinking, to elevate the primary living space. Away from ground moisture and predators, the builder turns to the canopy. Notching the bamboo before assembly creates a locking joint, significantly increasing the load-bearing capacity compared to simple lashing. A clean, angled cut prevents the ends from fraying under pressure. Lifting these green timbers into the branches requires balance and calculated leverage, utilizing the tree's natural forks as structural anchors. The foundation must be perfectly rigid. Nailing wooden floorboards directly into the green bamboo framework establishes a sheer diaphragm. This prevents the platform from racking or swaying as the tree moves in the wind. A solid deck is critical. It transforms a precarious perch into a functional workspace. Vertical uprights are positioned to transfer the load of the future roof straight down into the platform's reinforced joints. Holding the poles plumb while driving the initial fasteners is a delicate balance against gravity. A slight deviation here compounds into a crooked roofline later. The surrounding forest is indifferent to the struggle, teeming with life that thrive in the very moisture the shelter is designed to repel. Driving steel nails into bamboo can risk splitting the stalk if not struck cleanly. The tension of the wood fibers holds the metal tight once seated. The frame begins to define the interior volume. Thin lateral poles are added to brace the heavy vertical supports. This cross-bracing creates a triangulated matrix, stiffening the entire framework against lateral wind forces. The structure now acts as a single, cohesive unit. As the walls are woven into place, a black polyethylene sheet is lashed overhead, transforming the open frame into a dry refuge. The steep pitch of the A-frame is essential in a rainforest, accelerating water runoff to prevent pooling and minimize leak risks. With the canopy sealed, attention returns to the ground. Dry bamboo, cured and hardened, is processed for finer architectural details. Sawing through seasoned stalks requires a sharp blade and steady rhythm, as the brittle fibers resist the teeth far more than green wood. A raised planting bed introduces controlled agriculture to the canopy. Dark, humus-rich soil, packed over a moisture-retaining layer of banana leaves, provides the necessary nutrients for a suspended garden. Expanding the footprint requires terracing the steep, muddy banks. Woven bamboo panels act as a permeable retaining wall, holding back the damp earth. Navigating the root-choked terrain highlights the need for secondary shelters. Every cleared path is a calculated energy expenditure. Using a long bamboo pole as a lever amplifies the digging force, breaking through compacted clay and buried roots. The forest floor is a complex ecosystem of rapid growth and decay. Selecting a site with stable, cohesive soil is paramount for a dug-in foundation. The presence of young bamboo shoots indicates fertile, well-drained ground beneath the cover. Carving a deep footing hole ensures the structural posts extend below the slip line, anchoring the frame deep in undisturbed earth. Removing loose dirt from the bottom of the excavation prevents the massive wooden posts from settling unevenly over time. Sinking the green bamboo upright establishes the primary anchor for a new terrain-hugging frame that will resist lateral wind shear. Cutting a rough aperture into the hollow chamber of the bamboo prepares the column for a specialized locking joint. Splitting bamboo along its grain yields flexible, high-tensile strips. The natural fibers run perfectly straight, allowing a single machete strike to create uniform lengths essential for lashing. Adjusting the horizontal crossbeams against the irregular rocky wall requires precise friction fits to ensure stability. Flexible bamboo strips conform to the roof's curved profile, acting as natural strapping. This binds the rafters tightly to the rock face, securing the skeletal canopy against sudden updrafts. Broad palm leaves are nature's prefabricated shingles. Trimming the thick stems allows the fronds to lie flat, preventing wind from catching the edges and tearing the roof apart. Layering the vegetation from the bottom up ensures that rainwater cascades cleanly over the overlapping seams, shedding moisture exactly like feathers on a bird. The dense overlapping creates an immediate drop in temperature beneath the canopy. The shelter merges perfectly with the foliage. With precision joints locked in, testing the notched upright ensures the load transfers smoothly into the ground. Woven bamboo panels introduce a breathable membrane. The tight lattice blocks heavy rain and direct sunlight, while permitting cross-ventilation, which is critical for preventing mold in humid environments. The wire lashing provides modern tension to ancient joinery. A large, flat river stone serves as a foundation pad, preventing the vertical wooden posts from sinking into the mud. It breaks the capillary action that draws rot-inducing moisture up into the timber. Selecting a hearth requires careful observation of airflow and natural fire breaks. Positioning the fire near a stone cliff utilizes the rock's thermal mass to absorb and radiate heat back into the camp, warming the space long after the flames die down. The dense vegetation mandates a tightly controlled perimeter. Water management is a constant priority. Deepening a natural crevice beneath the boulder channels the stream, redirecting the flow to create a protected reservoir that won't wash away the soil. Prying out embedded stones widens the catch basin, slowing the water's velocity and allowing suspended sediment to drop to the bottom. Stacking wet river stones creates a gravity-retaining wall. The irregular shapes interlock, relying on their sheer mass to hold back the earth. Allowing small gaps between the stones permits hydrostatic pressure to bleed off safely, preventing the wall from blowing out during a flash flood. A sharp blade cleanly severs the capillary tubes of the green bamboo, leaving a smooth edge that won't trap debris or promote bacterial growth in water. The hollow, segmented structure of bamboo makes it an ideal natural conduit. Positioning the long pipe harnesses gravity to deliver fresh, running water directly over the newly built retaining wall. preventing the hydraulic erosion of the lower bank. Notching the pipe allows the builder to precisely control the volume of the spillway. Trimming the ends ensures a smooth, laminar flow without splashing. Lashing parallel poles together with flexible vines creates a sturdy, elevated deck. Utilizing the tension of the green wood to lock the raft into a rigid plane. The finished structure sits above the damp earth, providing a clean surface that separates the living area from the forest floor. Green vines shrink slightly as they dry, cinching the wooden joints with a vice-like grip over time. Tucked beneath the overhang, the shelter utilizes the boulder as an impenetrable rear wall, requiring only a fraction of the usual building materials. The river provides a constant, reliable pulse to the camp. Driving a wooden peg into the damp earth establishes a firm anchor point. The friction of the compressed soil holds the wedge tightly in place. Expanding the original treehouse demands clearing the surrounding choking vines. Removing the fibrous parasitic growth from the host tree reduces the weight on the branches and opens structural attachment points for scaffolding. Trimming the exposed surface roots creates a level staging area without compromising the tree. Reading the terrain dictates the next phase. The steep, muddy bank requires a structure that bridges the gap without destabilizing the fragile topsoil. Measuring timber directly against the living branches ensures a custom fit. Every cut must account for the natural taper and curvature of the tree. Uniform bamboo sections will soon form the rungs of a permanent access ladder. With the bamboo split and planted, a rigid ladder frame takes shape. Lashing the rungs close to the ground allows maximum tension on the joints before hoisting the heavy assembly into the canopy. Testing the floor's deflection ensures the cantilevered platform can support dynamic loads safely. Pulling long bamboo strips into the branches provides raw material for enclosing the elevated space. Carving deep notches into the thick uprights creates a mechanical lock for the horizontal beams. This subtractive joinery transfers weight directly through the solid wood fibers rather than relying solely on the shear strength of nails. Precise cuts ensure the intersecting poles sit perfectly flush against one another, minimizing in the surface area exposed to trapping, rot-inducing moisture. Every fraction of an inch matters when building a rigid frame in a living tree. Trimming the poles to exact lengths brings order to the sprawling raw materials. The canopy offers protection, but it demands absolute precision. With vertical supports locked in place, the skeletal frame transitions into a defined room. The rigid geometry resists the twisting forces exerted by the host tree swaying. Securing the woven walls from the inside creates a taut, impact-resistant barrier. The interior transforms from a wind-blown platform into a protected sanctuary. A continuous layer of woven matting deflects the intense tropical sun, casting deep, cooling shade. Clearing loose shale from beneath the rock, overhang prepares a flat bed. Leveling the dirt with heavy river stones establishes a stable, non-combustible foundation. Banana stalks are heavy with stored water, making them remarkably fire-resistant and excellent insulators. Harvesting the massive stems requires cutting them cleanly at the base to ensure the plant can regenerate. Transporting the heavy, wet logs is a test of sheer physical endurance. The rock overhang offers a natural, waterproof ceiling. Wedging the thick banana stalks vertically between the earth and the stone creates an immediate, insulated wall, closing off the exposed flank. Trimming the stalks to an exact friction fit relies on the natural compression of the spongy plant tissue to lock the wall tightly in place. Stacking heavy river stones at the base prevents the vertical stems from shifting under pressure. Pinning the wall with a horizontal bamboo pole acts as a structural rib, distributing any wind or impact force evenly across the entire organic facade. The porous, waterlogged stalks will slowly dry and shrink over time, but the rigid bamboo frame will hold the barrier intact. Shaving down smaller segments of the stalk yields thin, pliable ribbons, ideal for weaving damp-proof mats. The high water content creates a safe, insulated boundary for a contained hearth. Lashing a floor mat from the fibrous stalks provides a comfortable barrier against the cold stone ground. Arranging a ring of dense rocks contains the hearth and creates a thermal battery that absorbs the fire's energy. Dry twigs ignite quickly, feeding off the oxygen channeled between the stones. The heat drives out the residual dampness from the surrounding rock, fundamentally changing the microclimate of the cave. Collecting water directly from the moving current ensures the highest oxygenation and lowest bacterial load. The smoke rolls upward, curling along the natural stone ceiling before venting out, naturally fumigating the small space against insects. A split bamboo trough acts as a clean, elevated water basin. The vertical stalks seal the alcove seamlessly. It is a shelter born entirely from its immediate surroundings. Tackling the steep hillside requires aggressive clearing. The dense undergrowth holds the topsoil together, so stripping the slope is the first step toward a major earth-moving operation. The grade is unforgiving, but it offers natural drainage. The orange-brown clay is dense and compacted. Using a wooden pole to pry out heavy-field stones saves the edge of the machete. Every boulder removed from the trench becomes structural material for later. Widening the cut deepens the foothold, cutting into the thermal mass of the hill. The earth itself will soon become the primary insulation. Following heavy excavation, rough-sawn planks are cut to frame the retaining walls. Driving massive steel nails into the weathered lumber requires intense force, anchoring the joints to withstand the immense static pressure of the earth behind them. Assembling the framework directly inside the trench ensures a precise, custom fit. The wooden skeleton must be perfectly rigid to hold back tons of muddy soil. The exposed slope represents a constant threat of erosion until the timber walls are securely braced in place. Building a subterranean shelter demands over-engineering the primary supports. The heavy timber provides the structural confidence to push deeper into the bank. Heavy timber logs form a robust retaining wall. Hammering the logs firmly into the mud bed locks them together, creating a solid barrier that relies on sheer weight and friction to defy the sliding hillside. Packing excavated dirt tightly behind the newly stacked logs creates a solid backfill. This deadman anchor system uses the mountain's own weight to stabilize the timber wall. Thick, parallel logs form a low-profile, flat roof, spanning the trench to bear the immense weight of a living soil canopy. Draping a continuous plastic membrane over the timber prevents groundwater from seeping down. Securing a tough green mesh screen over the plastic gives the topsoil a textured surface to grip, preventing the upcoming earth layer from washing away during heavy rain. The parallel logs distribute the overhead load evenly down into the reinforced side walls. Clearing the surrounding path marks the transition from heavy earth, moving to the final stages of integration. Planting live grass directly into the roof, soil creates a living, root-bound mat. As the root systems interlock, they stabilize the earth and absorb rainfall, transforming the roof into a camouflaged, naturally draining membrane that blends seamlessly with the forest. Once the walls are sealed, precise carpentry finishes the envelope. Cutting lumber on a solid slab ensures straight, clean edges for the door frame. Heavy metal hinges secure the door, completing the subterranean seal. In the end, structure, landscape, and daily routine operate as one system, a place that produces, protects, and sustains itself.